very good morning my children. Myself, I am Vallika and I am a physics lecturer at RAMABANAM Junior College and I have an about of 18 years of teaching experience. In today's class, let us discuss on oscillations. In oscillations, we shall discuss what exactly is periodic motion, harmonic motion, oscillatory motion, simple harmonic motion and a special type of simple harmonic motion. Examples of this, that is reference circle and its characteristics. So these are the points which we are going to focus on today's class. So let us move in detail. First of all, as I said, periodic motion. What is periodic motion? What is periodic motion? Something which repeats itself at regular intervals of time, periodic, time to time repetition. So the motion which repeats itself at regular intervals of time is called as your periodic motion. That's all. And we have many examples of a periodic motion in our daily life. You would have observed that planets revolving around the sun in some circular pattern and this motion is repeated at regular intervals of time. Not only this, in chemistry, you will be dealing with the atoms, nuclear, electrons and all. In that also, electrons will be revolving around the nucleus in some circular pattern. And few more examples. Heartbeat. Heartbeats mean the pulses. It is a continuous process. Okay? The beating of the heart, if you observe the diagram, means the pulses will be up, down and so on, and this peaks if you observe, and these are repeated at regular intervals of time. And one more example we shall have means the strings of a guitar or a violin. Once it is plucked means the strings will start vibrating to and fro. So these are all come under your periodic motion which repeats itself at regular intervals of time. And now let us focus on harmonic motion. What is harmonic motion? See, in mathematics, you would have come across trigonometric functions like sine function and cosine function. So, any function that can be expressed in either sine or cosine function. The displacement, if you express in terms of sine function or cosine function, comes under your harmonic motion. Now, in order to understand in detail regarding the harmonic motion, let us consider a few more examples. You know oscillatory motion. If you consider a simple pendulum bob, so what happens means the bob, if it is, here is the simple pendulum, the bob of a simple pendulum is pulled aside a little and released. Then what happens? It starts oscillating. Okay? That means the to and fro motion about a mean position. Mean position means the fixed position. In general, let us name it as that center position. So, it go to the other extremist, comes to that place and again to the other side, and this process is repeated at some regular intervals of time. So, the simple pendulum is a better example for your oscillatory motion. Let us also understand what is vibratory motion. The same case, suppose if the strings of a guitar is pulled and released, as I said earlier, then what happens? The string starts vibrating. Even if a prongs of a tuning fork is struck by a rubber hammer, then these prongs will start vibrating. What makes the difference between the oscillatory and vibratory? Here the process is slow, that means the frequency is low, whereas here the frequency is more. But that means in one particular second it oscillates, it vibrates many number of times, but this is a slow process. Slowly, gradually it moves to and fro. That is the only difference between the oscillatory as well as your vibratory motion. And you need to remember, my children, every oscillatory motion, that is the to and fro motion about a mean position, is a repetitive motion. That means it is a periodic motion. But every periodic motion need not be an oscillatory motion, because the circular motion can never be considered as an oscillatory motion. That's all. So now, simple harmonic motion. What is a simple harmonic motion? This is what we are mainly going to focus in today's class. So what is simple harmonic motion? You know what is harmonic already I have introduced you, that sine function and cosine functions and all. So a body is said to be simple harmonic motion. A body is said to be a simple harmonic motion if it moves to and fro about a mean position. About a mean position, it should move the either of the side. A body is said to be simple harmonic motion if it moves to and fro motion along a straight line such that the acceleration and displacement both should be opposite in direction, though equal in magnitude but opposite in direction. I repeat, what is a simple harmonic motion? A body should move to and fro along a straight line about its mean position such that at any point acceleration is directly proportional to the magnitude of displacement. That means displacement the other side, acceleration, the same amount of acceleration in the opposite side. So magnitude of the displacement must be equal to the magnitude of the acceleration, but they must act in opposite direction. That's all. So let us look at the conditions in detail. So these are the conditions. What I told you regarding simple harmonic motion means the motion should be periodic. The motion should be periodic, time to time repetition, and it should be a to and fro motion about its mean position. Hope you understood this. And as just now I told you that acceleration and displacement, they both must act in opposite direction. Acceleration and displacement must act in opposite direction, and acceleration is always acting towards the fixed point, that is mean position. The direction of acceleration is towards the mean position, and this acceleration and displacement, how are they both related? Directly proportional to the displacement in negative y. Negative y indicates that opposite direction. Hope you understood. Okay. Now let us look at the examples of this simple harmonic motion. We have many examples. Suppose in general you would have observed that a mass loaded spring, a spring is taken, some mass is attached to it, and when by the application of some force it is being pulled down and released. What happens? This body starts oscillating up and down and up and down. If this is the mean position, the body comes down as well as it goes up, and this motion is repeated at regular intervals of time. So this is an also example of your harmonic motion. Not only this, you know the U-shaped U-shaped tube, some liquid is taken inside. Some force is exerted on one side, then what happens to the liquid? It moves to the other side, and when the force is released, comes to the same direction, and this process is again repeated. That is also an example of this harmonic motion. Well, but we shall focus on the main part, that is reference circle. This is entirely different from what examples we have considered till far. What is a reference circle? You consider a circle. Let us consider a circle. On this circle, let us assume a point P. See, some point P is there. This is a point P. Okay, so this is the position of the particle. This is a circle. For this circle, these two are diameters. Okay, this is along x-axis. So let me name it as x, center point as O, and this is some x dash. Along y-axis, this is y, O, and y dash. They both behave as the diameters of that. So what is a reference circle means? This particle is projected on diameter, either of the diameter may be vertical axis or horizontal axis. This should be projected on this. Okay. So what is a reference circle? The projection of a particle on the diameter of a uniform circular motion. Why I mean here as uniform circular motion means this particle moves around the circle with constant velocity, constant angular velocity, that be some omega. Okay. So, uniformly it moves about the circle. So, hence the name. So, this behaves as the mathematical model for a reference circle. Okay. Now, let us go in detail about this. To make you understand clearly, let us consider a circle. In this circle, suppose if a particle, some ball like structure is taken and a hole is inserted this. If you start moving it, the ball moves in the circular motion. Now, this is constant along the diameter, like pipe like structure, consider something. The same particle is inserted in that vertical pipe. Whenever you are performing like this, what happens means this particle is constrained to move only along one particular axis. Even though you are moving in circular motion, this will be moving in vertical direction. That means only along y axis. Suppose if it is constrained along x axis, that circular motion moves along x axis. Now you understood this. So, this projection of the particle along the diameter, okay, of a uniform circular motion behaves as a reference circle. Okay. Now, let us go in detail regarding this concept. As I asked you to consider a particle P, and let this particle be making an angle theta with the x-axis. If this is theta, what is this angle equals to? This is also theta. Why? Alternate interior angles. Along y-axis, let us name this as some small y, length. And along x-axis, if you suppose if you perpendicular, if you drop this means this length will be some x. Is that clear, children? Okay. Now, let us focus on this particular triangle. Let us name this as M and this be some N. What type of triangle is this? Yes, it is a right angle triangle, right angled at N. Now consider this value is y and this is nothing but this is the radius of the circle, and that radius of the circle, let me name it as A. For this right angle triangle, you know the value of adjacent side as well as your hypotenuse side. Okay, opposite side as well as your hypotenuse. So, from this, what is the value of opposite and hypotenuse? So, which trigonometric function comes under opposite and adjacent? Yes, it's true, sine. So, now consider sine theta. What is the value of sine theta? Opposite by hypotenuse. What length is opposite? It is y. What length is hypotenuse? It is A. Okay. Now, hence what is the value of y? Bring the A to the other side. How much is that? A sine theta. So, what is the displacement? Y is equals to A sine theta. But we know that from you learned it in system of particles, angular velocity is defined as the rate of change of angular displacement, that is theta by t. So, from this the value of theta is nothing but omega t. So, instead of theta, even I can replace the same with y is equals to how much ma? A sine theta is nothing but your omega t. Okay. The projection of the particle, as long as the particle is moving along the circular motion, the projection of the particle on its diameter moves along this vertical axis, and the displacement at any instant is given by the formula y is equals to A sine omega t. T indicates the time over here, A is your amplitude and sine function. The same thing you can calculate along x axis. So, let us try to find out the same along x axis. See, what is this? Particle P, and this is the position of the particle, and this length was taken as A, this is O, this is X and this is X dash. I now projected this particle along x-axis and I named it as some m. This angle was theta and this length was small x. For this theta, we know the adjacent side, we also know the hypotenuse. What trigonometric function takes the values of adjacent and hypotenuse? No doubt it is cos function. So, let us calculate cos theta. So, cos theta equals to adjacent side by hypotenuse, that is x by a. Bring this a here, then x is equals to a cos theta, or x is equals to, because theta can be replaced with omega t, a cos omega t. So, along x-axis the value is given by a cos theta or a cos omega t. Along y-axis it was y equals to a sin theta or a sin omega t. That is all. So, now let us look at detail regarding the characteristics of simple harmonic motion. First of all, displacement. See, in motion in a straight line and all kinematics, you came across displacement, velocity, acceleration, time period, many more things. Here also we are discussing about the same thing, that is displacement. What do you mean by displacement? The shortest distance, okay, along its path. But here the shortest distance between, here we are focusing on mean position. From mean position the body will move on the either side. The shortest distance between the mean position and wherever the particle is there, the position of the particle, this distance is termed as a displacement here. And just now we have calculated the values of displacement. What was their values? Along y axis, its value was y is equals to a sin omega t, and along x axis its value was considered as a cos omega t. That is all. Okay. So, this is what we have calculated. So, what is the displacement means? The shortest distance between the mean position and the position of the particle wherever it is. Well, next topic, amplitude. See, in the diagram I showed you that A, what is that A? The radius of the circle. Okay. In this reference circle, this length was taken as A. And the same thing, see, the particle can move from here to here, here to here, here to here, anywhere. But among all these lengths, which is the maximum? Its radius, and radius we have considered as A. So, the maximum displacement of this particle from its mean position, what is the maximum displacement? Up to its radius. The maximum displacement of the particle from is simply defined as an amplitude and termed indicated with the letter A. So, what is amplitude? The maximum displacement of the particle from its mean position is nothing but your amplitude. And in order to make a circular motion, it takes one complete circle means it takes some time. Similarly, if the particle is moving to and fro, up, down, or sideways, whatever the case is, it takes some time to start from, let us suppose some example, mean position it starts, goes to the one extreme position, again comes to the mean position, moves to the other extreme position and again comes back to the same. That means this complete process is called as a one oscillation. One oscillation. Earlier one circular motion and this is the straight line path is one oscillation. So, in order to complete one oscillation, it takes some time and that time is called as your time period. So, what is time period? The time taken by the particle to complete one oscillation is defined as a time period. Children, you know that in mechanics, kinematics, okay, we have speed is equals to distance by time. Hope you remember. Or time is equals to displacement by speed. Yes or no? Suppose if you discuss about a circular motion, a particle has started its journey here. In order to complete one circular motion, And if r is the radius of the circle, what is the distance covered? Yes, that is distance covered is 2 pi r. And now coming to the velocity, not velocity, speed. And in system of particles, you know you have come across the relation V is equals to r omega. So instead of V, I replace it with r omega. R gets cancelled. So what is the value of time period, children? That is 2 pi by omega. What is time period? The time taken by a particle to complete one oscillation. And what is the value of time period? T is equals to 2 pi by omega. Is that okay? Well. Frequency. What is frequency? It's nothing but frequency means the reciprocal of time period. Okay, and it is indicated with the letter F. So frequency F is nothing but your reciprocal of time period. Just now we have calculated the time period. How much is that, ma? 2 pi by omega. 1 by 2 pi by omega is nothing but omega by 2 pi. So frequency, value of frequency is how much? Omega by 2 pi. Now let us come to the definition of this. We have discussed, no? The body is oscillating here, there, the to and fro motions. In 1 second, how many oscillations are made? That is termed as a frequency. Maybe vibrations also. The number of oscillations made by the vibrating body in 1 second, how many times it can move the others, either of the side, that is termed as your frequency. Okay. Well, moving to the phase. Now this is entirely a different topic. What is phase? Earlier we'll come back to our previous concept, that is the circular motion. This was the particle. The particle has started its journey, and this angle we considered it as some theta. Okay, from here to here theta. Maybe there are cases where the particle may start at some angle, say phi, and it has displaced to some angle, say some theta. Okay, then what is the total angle from here to here? It is theta plus phi. But we know that theta can also be written as omega t plus phi. Okay. So this itself, this function, that is theta plus phi, is nothing but your omega t plus phi. This total angle is called as your phase. The total angle is called as your phase. And this phi itself, whatever is there in this term, the phi itself is called as an initial phase. That means beginning, at the time of instant, at the starting time where it is, and now where it has moved. So phi indicates the initial phase, and theta plus phi or omega t plus phi indicates the complete phase. Okay. So what is phase? The phase of an angle oscillating system at any instant indicates the state. That means where is its position, in what direction it is. So the phase indicates the position of the particles and the direction towards which it moves. Earlier I have told you, the phase is generally indicated by omega t plus phi. It happens when the particle is moving upwards. Suppose that the particle may also move downwards. In that case, it is taken as minus. So the phase plus or minus indicates the direction, and that function omega t plus phi totally indicates your phase. Okay. And among this, the value phi is your initial phase. Okay. Phase constant, 3 names are there. I told you initial phase at the beginning time, epoch, as well as phase constant. It indicates the state at which, the state of the particle with respect to time, as well as with reference to a fixed point. Here fixed point means mean position. That's all. Now that left over two more concepts, let us try to calculate the velocity and acceleration before we wind up. Okay. So what was the value of displacement, children? As we have calculated in your previous concept, that is, we have displacement y is equals to, along y axis means a sin omega t plus phi, only positive axis, upward direction we will be considering. But how do you define velocity? We know that velocity is nothing but the rate of change of displacement. Okay. Velocity is nothing but the rate of change of displacement, that is nothing but your dy by dt. That means you have to consider the derivative of this. A is a constant term and derivative of sine function. What is the value, children? A, derivative of sine function is cos function. So instead of sine, we have to replace it with cos omega t plus phi. And internal derivative, if you consider, phase phi is a constant, so derivative is 0. For this, derivative is omega. So totally the value of v is equals to a omega cos omega t. Okay. So what is the value of v? The value of v is equals to a omega cos omega t. Okay. Even you can also represent, we know that sin square theta plus cos square theta equals to 1. So cos square theta can also be written as 1 minus sin square theta. So this can also be written as a omega cos theta is nothing but cos square theta is 1 minus sin square theta, but cos theta means under root. So a omega root over 1 minus sin square omega t plus phi. And we know that previous knowledge, y is equals to a sin omega t plus phi. From this, the value of sin omega t plus phi. What is the value of sin omega t plus phi? Y by a. But here we need sin square omega t plus phi. Sin square means this term square, that is y square by a square. Hence the value of v is equals to a omega under root 1 minus sin square function, that is y square by a square. Simplify, a square minus y square. Denominator you have root over a square. Root over a square is nothing but a. That a and this a will gets cancelled. Let me write it like you for you. A omega root over 1 minus y square by root over a square is a. A gets cancelled. Hence the formula. Okay. So the value of v is equals to omega root over a square root over 1 minus y square. Okay. Now the last concept is your acceleration. What was the value of acceleration? Acceleration is defined as the rate of change of velocity. Okay. What was the velocity? We have just calculated a omega. Okay. Derivative of that was cos function, cos omega t plus phi. Acceleration means rate of change of velocity, that is dv by dt. So we need to consider the derivative of this. A omega is a constant term as it is. Derivative of cos function is minus sign. Derivative of cos function is minus sign. So minus, we will be writing it here, and here we have sine function. A omega sine omega t plus phi. This is the value of your acceleration, and it is not finished. Internal derivative also we have to do. So what is the value of internal derivative for this omega? And that omega, this omega will become minus omega square sine omega t plus phi. What was the value of y? Y is equals to a sine omega t plus phi. Here this is a, and this is sine omega t plus phi. A sine omega t plus phi can be replaced with y. Hence the value of a is equals to minus as it is, omega square as it is. Instead of a sin omega t plus phi, I replaced with y. The value of a is equals to minus omega square y. And clearly, as the particle is moving in a uniform circular motion with a constant angular velocity, that is omega. So, it is very clear that omega is constant. Hence, the acceleration, as this is constant, this is negative term and this is displacement. Acceleration is directly proportional to the displacement in opposite direction. Hence, the condition for simple harmonic motion. Okay children, hope you have understood. So, thank you. Let us wind up our today's class from here. Thank you.